Hello, College Algebra, and welcome to the second video of 4.5b, Rational Inequalities. Before we begin this lesson, I want to recommend that you get a calculator handy. Some of these examples probably will need a calculator. If you do not have a handheld calculator with you, I recommend going to this website. You guys are familiar with this calculator from previous lessons? eeweb.com/tools/calculator. It'll have all the functions you need. For this video, I'm not really going to be using this calculator because I have my own handheld. I'm just showing you this calculator in case you need to use it. So, there you go. There's a calculator handy if you need it. And before we start the main lesson, I do want to talk about this bell ringer. It's going to make this lesson very handy. So let's say you have two rational expressions, and we need to subtract them. And, I mean, looking at it, it doesn't look very pretty. But if you think about it, it's actually not that different from subtracting regular fractions. Like say, for example, let's say I have the fraction 7/4. That's a very lousy 7. There we go, 7/4. And let's say I need to subtract it from 3/4. There's some of you probably thinking, oh, that's easy. Since the denominators are the same, that means my denominator will be the same for my final answer. And that's true. As long as your denominators are the same, then that means you just really need to subtract the top. So in other words, you just have to do 7 minus 3, which is 4, and then your denominator will just stay the same. And of course, 4 divided by 4 is just going to give you 1. Now the same rule actually applies to the problem on top. Or in other words, take a look at the denominators. They're both the same, x plus 2, x plus 2, which means your final answer will also have that same denominator of x plus 2. All you have to do is to take the top two parts and subtract them. So let's go ahead and do that. Well, of course, let's first subtract the x's. So x minus x, well, x minus itself will just give you 0. So those are gone. And now you got to do -5 minus +3. So -5 minus +3. -5 minus 3, which will give you -8. So simplify from there. On top, 0 minus 8 is -8. And on bottom, you still just get x plus 2. So in other words, this problem did look scary. But as long as our denominators are the same, it makes it easy. It just means our final answer will have the same bottom, and you just have to worry about the top. We will be seeing some examples similar to that in this video, so I just wanted to give you a heads up on that. So today, we're going to be continuing with what we did yesterday, just with some more interesting examples. So in other words, for this example, what we're going to be ending up doing is we're still going to be doing what we did yesterday, where we're going to have to figure out what happens when we take the top and the bottom and set them equal to 0. We're then going to have to determine when the top and bottom has open or closed. And also we'll still have to graph the information we have and find our test values to plug and chug. But this problem is a little bit different from the ones we have worked on before, specifically because there's two rational expressions this time instead of just one. The previous video, we only had one rational expression set greater than or less than to 0. This time we have two. And what's going to happen here is we are going to have to move the rational expressions over to one side. So, what's going to happen here is I can either move this fraction over, I can move the -1x plus 4 over, or I can move the -5x over to the other side. Either way works. But for this example, I'm going to go ahead and move the -5x over. And how I'm going to do that is take a look at the minus sign and pretend that's a subtraction. In other words, to move it over, you got to do the opposite operation and add it over to both sides. So in other words, I'm going to take 5x or plus 5x all over x plus 4 to both sides. On the right side, everything will cancel, and then I just need to combine what's on the left. So on the left side, I'm still going to have negative 1 over x plus 4, but then I'm going to add that to 5x over x plus 4. Notice the negative is gone because we changed it to the plus. So that's all on the left. My inequality, in this case, is going to be less than or equal to x. And everything on the right side, as you notice, canceled, so there's nothing left on the right side. So I'm just going to put 0. Okay. So now what's left is that we got to combine these two functions. I got to combine those two fractions. But wait a minute. You have a common denominator, which means when you add these, I'm going to do that over here. When you add them, you're still going to have that same denominator on bottom. You just have to combine what's on top, the negative 1 plus 5x. But of course, you can't really combine a constant with the x variable. They're not like terms. So you can really only leave it as negative 1 plus 5x on top. And then have it less than or equal to 0. Again, the less than or equal to came from right here. And we didn't have to flip it because we didn't divide anything. We didn't divide any negatives. We only added. So we keep it just like that. And everything on the right side canceled. So we got it 0 on the right side. So now that we have that under control, we now have it down just to one rational expression and a 0. We can now do our main steps from yesterday. Ooh, I was about to sneeze. So first things first, we got to set the top and the bottom equal to 0 and figure out what those are going to be. So first, we're going to set the top equal to 0. So in other words, take negative 1 plus 5x equal to 0. I'm going to go ahead and do it over here. So negative 1 plus 5x equals 0. I'm going to do the easy stuff first. I'm going to take the minus 1 and add it over. So then that's going to give me 5x equals 1. And then the 5 is being multiplied, so the opposite would be to divide. And we will get x equals 1/5. Some of you are freaking out because you see that fraction. You're like, oh, do I have to plug in a fraction? Don't worry. Just trust me on this. For now, just keep it as x equals 1/5. Don't worry. It'll be fine. Trust me. But now let's go ahead, set the bottom equal to 0. So in other words, take the bottom, set it equal to 0, and you're going to get x equals negative 4. But just like before, we can't have the bottom equal 0, so you're going to put not equals. And since it's not equals, that means, as always open brackets for bottom. And also, we can move on. That tells us we can move on to the second step of deciding if we're open or closed. Bottom, always open. The opened will depend on the inequality, which in this case, the inequality is less than or equal to. The equal to sign means we got to do closed. Okay. Now we can move on to the third step, where we're going to graph and put in some test values. So let's go to the real number line and let's do our stuff. All right, so for the top, I'm going to have a line. It has to be between 0 and 1, since the fraction is 1/5. And we're going to have closed brackets on 1/5, because that's what the top is. Then at the bottom, we have negative 4. So right at negative 4, we're going to have a line, or a border line, and that one's going to have open parentheses. All right. So now we have 1, 2, 3 intervals. Let's pick our test values. For this one, we can pick any of these values as long as they're not on the blue border. I'm going to go ahead and pick a test value of negative 5 for this one. For this interval, I'm going to be safe and pick a test value of negative 1. And then on this side, looks like 1 is not touching the blue border. So I'm pretty sure it's safe to say that our test value can be positive 1 for the third interval. So just like before, we're going to plug these all into our expression and see which ones work and which ones don't. And I'm just going to copy down the function real quick. -1 plus 5x all over x plus 4. And we said it was less than or equal to 0. Okay, just going to double check. -1 plus 5x over x plus 4 less than or equal to 0. Perfect. So that's the function we're going to be working with. And let's plug in our first test value, of -5. This is where you're going to need your calculators. Your calculators are going to be handy for this one. So let's go ahead and do it. So -1 plus 5 times -5. Remember, that's times this time, not subtraction or addition. And then on bottom, we're going to have -5 plus 4. Okay, we've now plugged everything in. Simplify the top. You'll have -1 plus 5 times -5, which will be -25. And on bottom, -5 plus 4 is -1. Simplifying the rest from here, on top, add the two negatives to get -26. And on bottom, you still have -1. Minus a negative makes that become plus positive, which simplifies down to 26. Now, is 26 less than or equal to 0? Sadly, it is not. That is a false statement. So thus, the first interval does not work. Now, moving on to the second one. So again, we're working with -1 plus 5x all over x plus 4. Whoops. So -1 plus 5x all over x plus 4, all less than or equal to 0. This time we are trying -1 to see what happens. So, plugging in the values. For x, I'm going to put a -1 on top. On bottom, -1 plus 4. Simplify from there. On top, you'll have -1 plus 5 times -1, which is -5. On bottom, -1 plus 4, which gives you 3. Simplify the rest from there. -1 plus -5 will give you -6 on top. Bottom is 3. -6 divided by 3 is -2. And double check, is that less than or equal to 0? And that does work, because -2 is, our negative number is less than 0. So the second interval checks out, so we can shade it in as our answer. And let's just check the third interval to make sure we didn't make any mistakes. So again, -1 plus 5x all over x plus 4, and that's going to be less than or equal to 0. And this time we're going to test the third value, which is going to be 1. So let's plug those in. So -1 plus 5 times 1 all over 1 plus 4. Simplify from there. On top, we're going to get -1 plus 5, because 5 times 1 is 5. On bottom, 1 plus 4 is 5. Simplify the top, you'll get 4, and the bottom stays 5. So you just get 4/5. Now, is that less than or equal to 0? Sadly, a positive number is not bigger than 0. Or a positive number is not smaller than 0. So that is a false statement, which means the second or the third interval flops out. And check it out. As you learned from the last video, you know you have it right whenever your answers are alternating. So false, true, false, they alternated. So we know we're on the right track. So that means we can now formally write down our final answer. So for our final answer, look where we shaded. We shaded from -4 all the way to 1/5. So -4 to 1/5 is our interval. And let's check the brackets. For 1/5, we're going to have a closed bracket, as it says up here. And for -4, we're going to have an open bracket as we set up here. And that is our answer for the Hobbes program. That interval is where we'll find all the solutions that makes this equation true. And since there's only one interval, we don't need a union sign. So again, basically just doing what we did yesterday. The only thing that was different about this one is that we had to first rewrite this part so that it was written this way, which will make it easier for us. And that's going to be the main theme for this video. Okay, let's try another one similar. Let's try another one similar to that so you get some more practice. So this time we again have some two rational expressions when we should only have one. So in other words, I can either move this function over to this side, or I can move this fraction over to this side. It doesn't matter either way. Well, I think we've gotten really used to having the 0 on the right side. So what I'm going to do is I'm going to go ahead and take this fraction and move it over to the left. And in this case, the 5x, notice how it's positive. And of course, when you think positive, you think plus. So the opposite operation would be to subtract it. So subtract 5x to both sides. Okay? Whoops, sorry. So subtract 5x over x minus 3 to both sides. The positive 5x and the negative 5x will cancel that out. So then on the left side, we'll have -3 over x minus 3 minus the 5x, all over x minus 3. Here, the minus is acting like the subtraction sign or the negative sign for negative 5x. Cannot talk today. Come on. There we go. So in other words, -3 minus 5x. And then our inequality, in this case, is greater than or equal to. And on the right side, since everything cancels, that's just going to become 0. So now we just got to combine these two fractions. And lucky for us, the denominators are the same again, which means when we combine them, the denominator will also be x minus 3. X minus 3, x minus 3, x minus 3. We just have to combine the like terms on top. So -3 minus 5x. And sadly, actually, these two are not like terms, so we actually can't really combine them. We can only just write -3 minus 5x. And all that greater than or equal to 0. All right, we now have it written like we normally have it from the previous video. And once we have it rewritten like this, we can now move on to our normal steps. So first step, I'm going to set the top and the bottom equal to 0 and go from there. So let's do it. First things first, I'm going to go ahead and take the top, set that equal to 0. So -3 minus 5x equals 0. First thing I'm going to do, I'm going to take the -3 and add it over. So that's going to give me -5x equals 3. And the -5, it may look like subtraction, but it's actually being multiplied by the x. So the opposite would be to divide. So in other words, we get x equals -3/5. And that is what we'll get for the top. X equals -3/5. Easy enough. Now we're going to take the bottom, set it equal to 0. So x minus 3 equals 0. That's easy. You solve for that. And that's going to give you x equals +3. And as always, the bottom cannot equal 0. So we're going to set x not equal to 3. And as always have open brackets. Okay, So moving on to our second step. We already have that the bottom is supposed to have open brackets, but what about the top? Well, take a look at our inequality. It has the equal to sign. The equal to sign means closed brackets. So closed brackets for the top. All right, so we got steps 1 and 2 done. Now we can move on to the third step of graphing and finding test values. Okay, so let's go to the real number line. We're going to have a border at -3/5. It's going to be right about here between 0 and -1. So -3/5, and it's going to have closed brackets. And then the bottom will have a border at +3, so right here. And open parentheses at 3. Okay, so we have our intervals. Looks like we got 3 intervals. I'm going to go ahead and erase this out of the way just so it's not in our space. Okay, so I got 3 intervals. 1, 2, 3. For test value, I feel like it's going to be safe to say that we can use -2 for the first interval. Again, you can use any test value as long as it's not touching the blue border. And then for the inside, I can use 0, 1, or 2. It looks like 0, not really touching the blue border, so I think it's safe to use 0 for the second interval. The third interval, 4, it's not near the border, so I'll use 4. So those are our test values. Let's do some plugging and chugging. So that's going to be our function. So -3 minus 5x all over x minus 3 greater than or equal to 0. Just going to double check, make sure I copied that all correctly. -3 minus 5x, x minus 3 greater than or equal to 0. Perfect. All looks good. Let's plug in our first value of -2. Have your calculators handy. So -3 minus 5 times -2, because that's what we're plugging in, all over -2 minus 3. Simplify from there. On top, we're going to have a -5 times -2, which will actually make that plus 10. So -3 plus 10. And then on bottom, -2 minus 3 will give you -5. Simplify from there. On top, -3 plus 10 will give you 7. On bottom, you will get -5. So that's what that simplifies to. But is that greater than or equal to 0? And sadly, this is considered a negative number because of the -7/5. And a negative number cannot be greater than 0. So that is a false statement. So in other words, the first interval flops. Okay, so now we can move on to interval number 2. So again, -3 minus 5x all over x minus 3 is going to be greater than or equal to 0. And this time we're testing just 0. This should be easy to test. Okay, so plug in 0, -3 minus 5 times 0 all over 0 minus 3. Simplify from there. On top, you'll just get -3, and that just becomes 0. On bottom, you get -3. Simplify the top, you get -3. On bottom, -3 plus positive, which will just give you 1. And is 1 greater than or equal to 0? 1 is a positive. Positive numbers are bigger than 0. So that one works. So that means the second interval can be shaded as part of our answer. And just to double check, we should triple check the third interval just to make sure we didn't make any mistakes. So -3 minus 5x all over x minus 3 greater than or equal to 0. And this time, we'll plug it in 4. So let's plug it in. -3 minus 5 times 4 all over 4 minus 3. Simplify from there. On top, -3, multiply those, you get -20. On bottom, you get 1. And then simplify the rest from there. We're going to get negative 23 on top, 1 on bottom, which just becomes negative 23. And double check, is negative 23 greater than or equal to 0? It is not. A negative number cannot be bigger than 0. So that is a false interval. And make sure we're alternating false, true, false. Yes, our intervals are alternating, so this works. That's basically a clear sign to say that we did our math correctly. So then we can formally write our final answer. So look at the shading. We shade all the way to 3/5, and then all the way to positive 3. So we shade all the way from negative 36 to positive 3. And what are the brackets we use? For 3, it looks like we're going to have an open. For negative 3/5, we're going to have a closed bracket. No union symbol because we only have one interval, and that's going to be our Hawk's answer. Done, just like that. All right, do a couple more examples, and then we'll be good for this video. The next couple examples that we're going to look at, it's going to involve a little bit of factoring. You'll see why in a moment. All right, so for this one, again, we got two rational expressions, and we're only supposed to have one. I can either move this over to the left or to the right, or move this one over to the left. And actually, for this case, it's going to look a little different from what we compared to, but trust me, what I'm about to do will make the problem a little bit easier. So what I'm going to do is this time, I'm going to take the left rational expression and move it over to the right, which means our 0 is going to be on the left side this time, which will be a little bit different, but trust me, it'll be okay. So when I'm moving this fraction over, notice at the top is a positive 2. Positive meaning plus, so the opposite operation would be to subtract or minus. So I'm going to subtract the 2 over x squared minus 4x plus 3 to both sides. So minus 2 to the left and to the right. On the left side, positive 2 and negative 2, those will cancel. So that means on the left side, there's nothing left, so we're just going to have 0. Then here, we're going to have the inequality of greater than or equal to. And then on the right, we're going to have x minus 2. So x all over x squared minus 4x plus 3, and then minus the 2. So minus 2, minus 2. Minus 2 all over x squared minus 4x plus 3. Okay? And lucky for us, take a look at what we have for the denominator. They're the exact same. So when you combine them, their denominator, when you combine them together, the final answer will also have a denominator of x squared minus 4x plus 3. You just have to take care of the top, x minus 2. And of course, you can't really combine those, so you just put x minus 2 on top. And you'll still have 0 greater than or equal to that. Now, before we continue, it actually would be a big help if we factored this. Or more specifically, the bottom part can actually factor. Or in other words, we need to find two numbers that multiply to 3 but add to negative 4. And of course, there's only two ways to multiply to 3, 1 and 3, negative 1 and negative 3. And this one will work because it will add to the negative 4. So we'll put negative 1 and negative 3 into the bottom fractions. Factoring will help a lot when it comes to determining what makes the top and bottom equal to 0. So that's something new that you guys haven't seen yet. If you can factor, please do so. Okay, so now we have it written like this. We now have just one rational expression and 0 on the other side. Now we can move on to the main stuff. So then we're going to do the main stuff on the next slide. And as you see, I already have the answer we got from the previous, basically I have this rewritten on the next slide, so it's already good to go. It's already in your notes. So now we have that, let's continue. So first, as always, I need to take the top and bottom and set them equal to 0. So for the top, set it equal to 0, and you're just going to get x equals 2. Now for the bottom, notice how you have 2 factors this time, which means you're going to have 2 numbers that you're going to have to set for the bottom. You're going to have x equals 1 and x equals 3. But as always, the bottom cannot be equal to 0, so you say x not equals 1 and x not equals 3. And as always, they are going to get open parentheses. And both of them will get the open parentheses because they're both part of the bottom. And there you go. And then for the top, what intervals what brackets will it have, open or closed? Take a look at your inequality. That's going to tell you closed bracket. All right. So now we got all the information we need to find our intervals and our test values. And just so you know, things are going to be a little tight. Well, first, we're going to have a border at 2, and it's going to have closed brackets, because that's what it says for the top. Then for the bottom, looks like we're going to have a border at 1, and that's going to have open parentheses. Yeah, some of you already are like, ooh, these borders are really close. And then we also have 3 as a border. And that's going to have open parentheses as well. Oh, that looks a little tight. And some of you are probably realizing, oh, our test values are not going to be pretty. And yeah, they're not going to be pretty. Well, and also, let's point out, now we have 1, 2, 3, 4 intervals this time instead of just 3. So we're going to do a little bit of plugging and chugging for this one. So brace yourself. All right, so let's first pick a test value for the first one. I'm going to pick that the test value for the first interval will be 0. Now for the second one, we're strictly between 1 and 2, which means my test value is going to have to be a decimal. I'm probably going to pick the easiest decimal that we can think of. I'm going to pick 1.5, because that's in between 1 and 2. So 1.5. And now this third interval is between 2 and 3. Again, that's going to have to be a fraction as well, or that's going to have to be a decimal as well. And right in between 2 and 3, let's go ahead and pick 2.5 as a test value. And then, of course, the last one, let's go ahead and pick a test value of 4 for the last one. Again, something you can use. You can use the fact that the intervals are going to be alternating to help you out. I'm just going to go ahead and plug in everything just so you guys can check your work. So we need to do some plugging and chugging. So this is the function we're going to be using. Let's write that down. So over here, I'm going to put 0 greater than or equal to x minus 2 all over x minus 1, x minus 3. And let's go ahead and plug in the first test value, which is going to be 0. Again, if you need to, have your calculators handy. And plugging in values for this one's going to be a little bit different this time. And also, I'm going to go ahead and just write 0 greater than or equal to from here on out. So 0 greater than or equal to, I'm going to go ahead and plug in 0. So 0 minus 2 on top, and then 0 minus 1, 0 minus 3. Simplify from there, 0 greater than or equal to On top, 0 minus 2 is negative 2. And then we're going to have negative 1 and negative 3 in parentheses. Now, some of you will probably look at this and say, oh, it's going to be negative 2 over negative 4 when you simplify. Here's the thing. That's what you would get if you added the bottom. But the bottom is not addition. The bottom is multiplication. The parentheses assume multiplying. So you actually have to multiply the bottom. Multiply negative 1 and negative 3 to give you positive 3. And let's double check. Is 0 greater or equal to negative 2/3? Yes, 0 is bigger than a negative number, so this works. So in other words, we can shade the first interval. And the first interval is going to be part of our answer. Now, some of you can probably say, oh, so now I can just alternate and then I'll have my answer. I'll have my two intervals. You can do that if you want at your own risk. I'm going to play it safe. I'm still going to plug in every single value just to make sure. If you just go ahead and assume they're alternating and assuming that you did all the math correctly, go right ahead. That's up to you. All right, so I'm going to go ahead and erase my work for the first one. Now I'm going to do the second test value. I'm going to plug in negative, or I'm going to plug in 1/5. And if my math is correct, it should give me a false statement. But let's find out. So 0, greater than or equal to. I got to plug in 1.5 for each x. So 1.5 minus 2, all over 1.5 minus 1. And then 1.5 minus 3. Simplify from there. On top, probably going to need a calculator if you need to. 1.5 minus 2, that should give you negative 0.5. On bottom, 1/5 minus 1, that should just give you positive 0.5. And then 1.5 minus 3, that should give you negative 1.5. Okay, go from there. On top, you're going to have negative 0.5. Now you got to multiply the bottom. You got to multiply 0.5 times negative 1.5. And it should give you negative 0.5 or negative 0.75. And lucky for us, minus a negative makes that plus positive. So now you just have to divide those. So, in other words, 0.5 divided by 0.75. And that's going to give you 0.66 repeating. And is 0 bigger than 0.66? Or is 0 bigger than a positive number? No, 0 cannot be bigger than a positive number. So that is a flop. So the second interval, that tiny little interval, is a flop. Okay, 2 more intervals left to go. So now I got 0 greater than or equal to x minus 2 all over x minus 1, x minus 3. And again, if they're alternating, that should tell me that my test value here is going to give me a true statement. But let's find out just to be sure. So let's plug in our test value of 2.5. Okay, so 0 greater than or equal to 2.5 minus 2 all over 2.5 minus 1, 2.5 minus 3. Simplify from there. Oops, too far. All right, so 0 greater than or equal to 2.5 minus 2, which should just give you 0.5. On bottom, 2.5 minus 1 should be 1.5. And then 2.5 minus 3 will give you negative 0.5. Go from there, 0 greater than or equal to 0.5 on top, multiply the bottom, multiply 1.5 and negative 0.5. And that's going to give you negative 0.75. Do the rest from there. Got to do 0.5 divided by the bottom. So 0.5 divided by negative 0.75. And you're going to get negative 0.66 repeating. And yes, 0 is bigger than a negative number. So that checks out. So that means the third interval is a true interval. So I'm going to shade in that third interval as part of our answer. Okay, one more interval to check out just to make sure that we got it. Sorry. All right. So one more test value to check out. We're going to try plugging in 4 this time to see what happens. All right, so I'm going to plug in 4. 4 minus 2, 4 minus 1, 4 minus 3. Go from there. So 0 greater than or equal to 2 on top. On bottom, we're going to have 3 minus 1. So 0 greater than or equal to 2/3. And it's basically saying, is 0 bigger than a positive number? That is false. 0 cannot be bigger than a positive number. So that flops. So our fourth interval is a flop. And then let's just check. We got true, and then false, and then true, and then false for our test intervals. That is alternating, so we're good to go. So now we can erase the bottom part and formally write our final answer. So let's check all the shaded intervals. For this one, we're shading from negative infinity all the way up to the border of 1. So negative infinity, comma, 1. For the intervals, negative infinity is always open. For 1, looks like we've got an open bracket right here. So that's an open bracket there. Now the second interval we shaded was right here, right in between 2 and 3. So 2, 3 is our second interval. And let's take a look at 2. 2 had a closed bracket, and at 3, we had an open bracket. And since we have 2 intervals, use a U symbol or a union symbol, and then you officially have your Hawk's answer. So that one was a bit rough, and chances are you may come across an example like this when you do the online homework. And that's why I went through the entire example. I went through and plugged and chugged everything just to double check. Because sometimes kids really like to rush. They'll do a calculation wrong, and then they'll just assume, oh, it's alternating from there, and then the whole thing is gone. The whole thing is wrong. Usually for this problem, you need to take your time. You need to double and triple check. So then you don't have to keep redoing this problem. That's the main reason why this lesson is so difficult for kids, is because kids want to rush. Do not rush. If you rush, you will get some of these problems wrong. So please take your time. Do not rush. As you saw, I did not rush this problem whatsoever. I did every single step. So we'll do one more example with this, and then that will be the end of video 2. Okay. So again, I have 2 expressions. Two rational expressions. I just need one. And what am I going to do? Got it. What I'm going to do is I'm going to move this fraction over, just so the x is in front. And in this case, I have a negative 3, which stands out as a minus. So the opposite operation would be to add it, or to do plus 3 to both sides. So plus 3 over x squared minus 25 to the left and to the right. Okay? So on the left side, the -3 and the +3 will cancel out, which means on the left side, I just have 0. My inequality is greater than or equal to, and on the right, I have x all over x squared minus 25, and then plus 3 all over x squared minus 25. Plus 3, plus 3. Looking good. And lucky for us, we have common denominators, common bottoms, which means we just have to combine the tops. So let's go ahead and do that. We'll still have the same denominator of x squared minus 25. We're just going to do x plus 3. Again, not like terms, so you can just write x plus 3. And that looks pretty good, but we're actually not done yet. It turns out we can actually factor some more. Because if you look at the bottom, it is missing a middle term. But when you're missing the middle term, you assume it's 0. This is actually x squared plus 0x minus 25. So when you're factoring, you're finding two numbers that multiply to 25, but will cancel out when they add, which of course only gives you one possibility, +5 and -5. Or in other words, x minus 5, x plus 5. Because -5 and +5, that multiplies and then adds to 0. There you go. That's how you factor that one. And now we have the function we need to help us find our final answer. So let's go ahead, let's take this and move it to the next slide. So 0 greater than or equal to x plus 3 all over x minus 5, x plus 5. Basically the same function that we had on the previous slide. All right, moving on with our usual procedure. Take the top and the bottom, set them equal to 0, and see what we get. Take the top, set it equal to 0. You're going to get x equals -3. For the bottom, you're going to set both factors equal to 0, which means you're going to have two bottoms. You're going to have x equals 5 and x equals -5. And as always, for the bottom, set them not equal. And as always, they are always going to get open parentheses. Done. But of course, for the top, we got to look at our inequality. Our inequality is greater than or equal. The equal to means close brackets. All right. We now have the information we need to graph and find some test values. Let's do it. So for the top, we're going to have a border at -3. And at -3, it's going to have closed brackets. Good. And then for the bottom, we're going to have a border at +5. And that one's going to have open parentheses. And then we're also going to have a border at -5. So I'm going to put -5 right here. Open parentheses. Whoops. Open parentheses. And there you go. Those are our borders. And it looks like we're going to have 4 test intervals this time, which means 4 test values. So our first test value, I'm going to go ahead and pick -6. For this one, looks like I can go ahead and pick -4. Yay, no decimals I have to plug in. For the third one, I'm going to pick 0. And then for the last interval, I'm going to pick 6. All right, so those are our test intervals that we're going to test. And we're going to be using this function. So let's do it. So 0 greater than or equal to x plus 3 all over x minus 5, x plus 5. Okay, looking good. All right, so again, let's plug and chug and let's see what happens. The first value I'm going to plug in is -6. for the first interval. So 0 greater than or equal to -6 plus 3 all over -6 minus 5, -6 plus 5. Go from there. So on top, -6 plus 3 will be -3. On bottom, you'll have -11 times -1. And simplify from there, you'll have -3 on top, and on bottom, -11 times -1 will be 11. So double check, is 0 bigger than a negative fraction? Yes, it is. 0 is always bigger than any negative. So that means our first interval is true. So let's shade it in as a true answer. All right, so now let's check the second test value. Let's plug in -4. Let's see what we get. So 0 greater than or equal to, plug in -4 plus 3 all over -4 minus 5, -4 plus 5. Go from there. 0 greater than or equal to, on top we're going to have -1. On bottom we're going to have -9 times 1. Simplify from there. You'll have -1 on top. On bottom, -9 times 1 is -9. And 2 negatives divided makes that plus positive. So, is 0 bigger than a positive fraction? No, it is not. 0 is not bigger than anything that's positive. So that is false. So the second interval is a flop. Okay, halfway done. I'm going to move to the right side of the screen to do the rest of my plugging and chugging. So x plus 3 all over x minus 5, x plus 5. Okay, and this time we're going to be testing the third test value, which is 0. So let's plug in 0. So 0 plus 3 all over 0 minus 5, 0 plus 5. Go from there. Here we're going to have 0 greater than or equal to 3 on top, -5 on bottom, +5 on bottom. And that simplifies to 0 greater than or equal to 3 all over -25, which is technically the same thing as -3 over 25ths. So, is 0 greater than or equal to -3 over 25? This would be a true statement because 0 is bigger than any negative. So that means we can shade in the third interval as part of our answer. All right, one more interval left to try, and then we'll have our answer. Let me erase the rest of the work. Okay. All right, let's do it. Last test value to plug in is we're going to plug in 6 and see what happens. So 0 greater than or equal to 6 plus 3 all over 6 minus 5, 6 plus 5. Just plug it in 6. Going from there, 0 greater than or equal to, on top we'll get 9, on bottom we'll get 1 times 11, which simplifies down to 9 over 11. And is 0 bigger than a positive fraction? Nope. 0 cannot be bigger than a positive fraction. So the fourth interval is a flop. And let's double check to see if we're alternating. So the first one was true, then false, then true, then false. They were alternating. That means we did all the math correctly. So with that said, we can now write our official final answer. The First interval, we shade from negative infinity all the way to negative 5. So negative infinity to negative 5, because that's where the border is. And what are the parentheses? At negative 5, we got open. And of course, negative infinity is always open. Now the second interval, looks like we're shading from the blue border of negative 3 all the way to the blue border of 5. So negative 3, comma 5. And what intervals or what brackets do these get? Negative 3 looks like we got closed. And at 5, we got open. And since we have two intervals as part of our answer, we're going to put a union symbol, and then we have it. This is our Hawk's answer. And that sums it up for part 2. Part 3, we're going to be looking at some examples where the denominators will not be the same. And we're going to have to figure out how to solve those. So, with that said, we will talk about that in part 3. But for now, take a break, and I'll see you guys soon.